Okay, guys. Yeah, hi. Good morning, all of you. Very good. I hope everyone maintains your energy levels. Today, let us start the last topic of electrostatics. It is nothing but electric flux. Okay, first of all, what is meant by electric flux, and why should we discuss about the electric flux? Exactly, what is the vision of electric flux? Let me explain. Just imagine a charge either plus q or minus q at this location. Its the field shape is 2D or 3D. Can anybody? Field means for positive charge it is away from it, for negative charge towards it. For positive charge field, how to define? If you can leave a unit positive charge at that location, the free path of the positive charge is called field and field direction. So if I can leave the unit positive charge nearby this charge in 3 dimension, it can move in all the directions. This exactly in 3D vision, the shape of the field is a sphere. Is it right or wrong? But due to point charge and dipole, till now we discussed up to plane only. Now again the field and potential and force is due to these perpendicular planes. The concept itself is called electric flux. Now you got my point clearly. Once again I'll repeat the point. For this charge alone, it has a field in xy plane and in xz plane and in yz plane. You know all the concepts like electric field, potential and force in xy plane. Till now we discussed already due to point charge and dipole. The same physical quantities in perpendicular planes. That discussion is called electric flux. The concept name is. Now to study about that electric field, what is meant by flux already you got the clarity. Let us take a definition as per the NCERT, that is the number of lines of forces that can pass through an area in which direction? Perpendicular to it. Is it right or wrong? The number of lines of forces is nothing but field that can pass through an area which are perpendicular to that considered area. And when we come to like mathematical form, if you can imagine a uniform electric field, so the field strength is E. The field strength is E. In this field, let me imagine some area which is in a random direction, and that area makes an angle theta with the field. So between these two means the field through this area is called flux in perpendicular direction. But that flux is a scalar quantity. In mathematics, a dot product or cross product, which gives scalar? Dot product. So we can write it as E bar dot A bar. Or else no need to follow any sign rule, right? Because it is a scalar. A bar dot E bar, which gives as E A cos theta. Okay, it is mathematical form, but the most important point. Once again, I'll repeat the point the theoretical way. Whatever the charged body it is, the first step, first to draw the shape of that charged body. Which shape? Electric field shape. Second step. In that electric field shape, how many planes we have? Maybe cylindrical plane, maybe circular plane, maybe rectangular plane. Different planes will come. Choose its area and immediately imagine it's perpendicular. If that perpendicular is also perpendicular to the given field, then flux will exist. Let me give the clarity for that in mathematical way. If I resolve this area into two components, one is A cos theta, which is along the field. Another one is A sin theta, perpendicular to the field. Now imagine, if you consider this area, it's a perpendicular, is parallel to the field. But our flux concept is perpendicular. Why should we imagine perpendicular to area? In definition itself it is there. Number of lines passing through an area. In which direction? Perpendicular to the area. So to the given area, immediately imagine perpendicular. Got my point clearly? Yeah, now the point is. So for A sin theta, its perpendicular is parallel to field. So flux will be 0 for that. If you consider A cos theta, its perpendicular is also perpendicular to the field. So flux can exist for that. That is theoretical explanation. Means, let me give you the clarity also. If any charged body, field is in the shape of a cylinder. Means how many type of shapes here we have? Cylindrical surface and circular plate surface, right? So their areas are perpendicular to their planes, and its perpendicular is also perpendicular to the field. Flux can exist. Its perpendicular is parallel to the field. Flux cannot exist. So that field shape will comes for a uniformly charged rod. Accepted? Everyone. Now if you consider uniformly charged sheet, on both sides if it has positive charge, which has the same field but in horizontal direction. Here also again two type of shapes. If you consider the cylindrical area, its perpendicular is parallel to field, so flux cannot exist. Circular plate area, perpendicular is perpendicular to the field, so flux can exist. Now you got the clarity, everyone? How to check theoretically and how to check mathematically. So now the scientist Gauss enters and explains that this relation between this flux to enclosed charge. Means Gauss explains in a different way. What is the different way? Let me explain. For example, here there is a plate which is placed on this plane, and from this plate, from the center, at a perpendicular height a by 2, here if I can place a charge q, sorry, from that charge, the field lines will move in all the directions. Now the question is, how many lines can pass through this plate and in which direction? Perpendicular to the plane of the plate. For that, let us apply small concept. Same plate, let me assume here, symmetrically. And if I can close this charge again symmetrically, now the point is, now the charge is at center for this cube, and at center it gives the field lines in all the directions. How many faces we have for cube? 6 faces. Means in each face the number of lines passing is same. Acha, if flux is through the complete cube, if the flux is 5, then through one face, what is the flux? We can say 5 by 6, because it can uniformly it can spread. You understood my point clearly? Once again I'll repeat the point, guys. Whatever the given charge, try to enclose it symmetrically. Try to enclose it symmetrically. Now the flux due to that charge for that symmetrical shape is 5. Now for the given part, maybe that is 1/3 part or half part or 1/6 part, we can easily split. Got it? Like let me ask one more point for that. If it is a hemisphere, the charge is at the center of the sphere. What is the flux or the number of lines passing through this area? Tell me. 5 by 2. Because to enclose this charge, we have to enclose it symmetrically. Now through the complete spherical surface, what is the flux? 5. Through hemisphere, 5 by 2. So imaginary to real concept. Now you got my point? So by using flux, guys, in mains point of view, we can calculate the electric field and enclosed net charge. Electric field and enclosed net charge. For advanced point of view, with respect to solid angle, we will discuss. With respect to solid angle. For example, let me discuss the point here. If there is a enclosed surface plus Q1 minus Q2 plus Q3, or the enclosed charges plus Q4 and minus Q5 are the charges at outside of the closed surface. Now, The flux explains us that due to the all charges, what is the net field inside the enclosed surface? Means for positive charge, the field lines are away from it, and for negative charge, towards it, positive away from it here. Like due to this negative charge, towards, for this positive, away. So the total charges inside and outside the enclosed surface, due to the all charges, what is the net field inside the enclosed surface? That can be explained by using flux. In flux, whatever the field we are using, that is due to all the charges. Second usage, we can calculate the net charge that is only enclosed. Means for net charge, if you want to take, only inside net charge only you have to consider. Outside charge don't consider. You got my point? Because to apply the flux concept, the charge should be enclosed. This is a mandatory form. Now, completely come back to basic form. What is the electric field due to this point charge? Electric field Kq by R square based on the theoretical definition we derived. Now, my point is, let me apply the flux concept to it. E dot A. What is area? Maybe we don't know. Just imagine. Electric field. Then E dot 4 pi R square is the flux. That flux is 1 by epsilon naught times that of enclosed charge. That is the simplest law given by Gauss. Simplest law given by Gauss. Whether it is right or wrong, let us see. Then E equal to 1 upon 4 pi epsilon naught Q by R square. Of course, that is our form. Is it right or wrong? So once again, I'll repeat the point. Generally, flux concept is the dot product between E bar and A bar. But whenever Gauss enters, the meaning and the vision of the flux itself completely changed. What is the vision? Flux means, first we have to imagine the given charge should be symmetrically enclosed. Then through the given part, what is the flux? Or what are the number of lines passing through it? That is the first vision after Gauss enters. And the second point, mathematically, if the number of lines of forces passing through an area in a perpendicular direction, then the flux is 1 by epsilon naught times that of net charge enclosed. Net charge enclosed. All these statements are correct for uniform field. If it is a non-uniform field, then we will introduce mathematics. What is that form? The closed surface line integral. What is the meaning of that? The given charge should be enclosed. Then only we can apply the integration into E dA through the small area. What is the flux? Integration, sum of all those. So total flux is enclosed charge upon epsilon naught. Accepted? Is it clear, guys? So what are the two simplest forms? When field is constant, E dot A is equal to Q upon epsilon naught. When field is variable, integral E dot dA equal to Q upon epsilon naught. Now that is also for 3D, but in a particular perpendicular direction. Means again we come back to 2D. But if the question or the diagram related to 3D, then how to calculate the flux? Guys, all these diagrams you observe, is it in 2D or 3D? If the given diagram will exist in 3D, here the diagram exists in 2D, flux will be in 3D. My question is, if the given diagram itself exists in 3D, then these formulas are not applicable. You got my point? Okay, the difference let me explain. The difference is plane angle and solid angle. Only advanced concept, guys. For plane angle, generally how to calculate the plane angle? Maybe this is our eye position and here there is a line AB. What is the angle made by this line at our eye position is called generally plane angle, which the unit for this one is radian. How to calculate that? Choose I is a center, and with respect to this center, draw a arc at a radius r. What my point? At a radius r. Now what is this? Length of the arc. Mathematically we can calculate, but physically. And radius also we know, because arc is our choice completely. So the plane angle can be written as length of the arc by radius. There is general method. What is meant by solid angle? This is plane angle, okay? Solid angle. Again, same eye position, but here now it is not the line. It is a plane, just like square plane. Imagine a square plane which is subtends the all corners at the center of the eye. The angle subtended by the all corners at the eye position. That angle is called solid angle. So solid angle is completely 3D angle. Got my point clearly? How to calculate this? Again choose eye is your origin, I mean center. Draw the spherical surface. Draw the spherical surface. Okay? Now, the shape of the spherical surface for this image will be accepted, everyone? Accepted. Maybe say this area is A and its radius is R. Now here the solid angle is defined as, symbol is omega, area upon R square, and its unit is steradian. Unit is steradian. So what is meant by solid angle? It is 3D angle, simply 3D angle at a center. What is plane angle? 2D angle. That's a 2D angle to 3D angle. Now got some clarity between these two? And next. Okay guys, any doubts in that? Yeah.
Sir, is there any relation between solid angle and plane angle?
Yes, very good. We have. Let me prove that. Please sit down. To get that relation, let me choose cone as an example. Okay. So here it is the center for a cone which makes a cone angle alpha, half of the cone angle at that center. And the end of the cone, if I can draw a spherical surface like this, spherical surface, and which gives a hemisphere. So the cone makes an angle, half of the angle alpha at center, and a spherical surface makes an angle omega. Total solid angle is how much? Omega. Clear? Now, to get the relation between these two, first, from the center onto the surface of the hemisphere, let me imagine an element at an angle theta and theta plus d theta. So the shaded part is our element, which is subtends an angle d theta. So your theta varies from 0 to alpha. The area that can swept out by this element is periphery into its radius. I mean thickness. What is thickness here? Length of the arc, r d theta. And what are the radius for this opposite side for this triangle? Then how much it is? R sin theta. Accepted? R sin theta, because opposite side for this triangle. Periphery 2 pi r sin theta into thickness r d theta. This is the area that can swept out by that element. What is the total area swept out by the hemisphere? Integration of that. And the limits are 0 to alpha. Theta is variable here. So 2 pi r square integral sin theta d theta minus cos theta. So lower limit cos 0 1 minus upper limit cos alpha. 2 pi r square into 1 minus cos alpha is the area swept out by the hemisphere which is on the surface, spherical surface at center. Now, the solid angle made by it is that area by r square. R square get cancelled. 2 pi into 1 minus cos alpha. Relation between solid angle and cone angle. Okay. Last 3-4 years onwards, so many times you asked the question in advanced exam based on flux related concept with respect to solid angle. What the relation between these two? For example, in 3D, if you try to apply the Gauss law, then what is Gauss law? Closed surface line integral E dot dA equal to Q upon epsilon naught. This is for total angle 4 pi. Total sphere means 4 pi angle. For solid angle something which is not 4 pi, maybe pi or pi by 2, anything it will come. For that solid angle, what is the total flux? Then for comparison, we will get omega by 4 pi. Q by epsilon naught is the flux for total angle. Then through solid angle, what is the flux? Into omega by 4 pi. Now it is clear now? So flux in 2D, first question. That is integral E dot dA equal to Q by epsilon naught. Flux in 3D, integral E dot dA that equal to Q upon epsilon naught into omega upon 4 pi with respect to solid angle. Are general some questions related to solid angle and cone angle, you asked the questions. I think 2021 you asked that question. He gave the solid, actually this one cone angle, he gave information to calculate. From that solid angle we have to identify. That is for advanced paper. Okay, clear? Any doubts? Yeah.
Sir, can we relate Coulomb's law with Gauss law?
Yeah, why not? And in fact, we will derive the Coulomb's law by using Gauss law. Shall we? Yeah, very good. Sir, what is Coulomb's law, guys? If two charges Q1 and Q2 are separated by some gap, force of interaction between them, Coulomb force, K Q1 Q2 by R square. Now, generally how to calculate the force for our concept? First we have to calculate the field and then F is equal to EQ. It's clear now? Now my point is, due to the Q1 charge, here field I want to calculate. Let it be said this is the radius R and let me draw a circle. So Q2 is the charge which is placed in the field of Q1. Now clear now? So for Q1 apply flux concept. E dot A. What is A? 4 pi R square. That is equal to. Here E is due to charge 1. Q upon sorry, epsilon naught. Now, what is the field due to this E1? 1 by 4 pi epsilon naught Q1 by R square. Accepted? Indirectly, it is the proof for electric field. In that field, Q2 charge is there. Then how much force it experience? E to Q. Accepted? I mean E1 Q2. Yeah, if I substitute E1 value, 1 upon 4 pi epsilon naught Q1 by R square into Q2. So Q1 Q2 by R square. So the Gauss law will derive the Coulomb's law. You got my point? But when we discuss the Coulomb's law, it is just like as theory. F proportional to Q1 Q2, F proportional to 1 by R square. But here it is the derivation. Clear? Very good. And remember guys, everyone understood the concept? And still anybody have doubts? Anybody? Yeah, thank you.